We make a lot of mistakes when we're alerting on things. We set up way too many alerts. We have information that we barely understand or don't understand what it means, but we set a threshold on it anyways. We have things that send us pages and phone calls constantly. We don't know what they mean. We ignore half of them. We never really know how big our problems are until they blow up in our faces because we were ignoring all the alerts all along. So, how do we get ourselves out of this? How do we deal with this crisis that we've created for ourselves of really, really bad monitoring that we can't trust and we can't get any information out of? Let's look at the problems that we create. So the first one that I've got is our network operations center. So our site operations center, and so I changed the name there. Our site operations center at LinkedIn is actually composed of some really smart engineers. These guys are amazingly good at what they do, and their jobs are stressful, and they have a lot of coordination and communication work to deal with. They build tools, they build processes around how to handle incidents, how to monitor site growth. It wasn't always this way. So we used to call them the NOC, just like pretty much everyone else does. And their job at the time was more like this. It was more like being a switchboard operator. We didn't have a good way to get alerting information directly from the systems to the SREs who were responsible for those systems. So what we did instead is the NOC had dashboards that they would curate with all of the really important alerts. So first, you had to prove that your alert was good enough to the NOC for them to monitor it. Then you also had to give them a run book for what to do when this alert went off. Most of our run books all said the same thing. It was call the SRE. This is not helpful. This makes the NOC engineers feel really bad because they can't do anything. All they can do is, oh, an alert's going off. Let me go pick up the phone and call someone. This is not helpful. This is not useful work for them to be doing. So we've made this a lot better. We've actually transformed our NOC into our site operations center. They're now responsible for overall growth metrics monitoring, and they're also responsible for coordinating incidents. But all of the alerts go direct to the engineers now, whether that be an SRE or a developer. This means the NOC is no longer playing a game of phone tag and trying to figure out who to call or who to engage. We generally bring the problems to the SOC instead, and then say, okay, we need you to get these 4 or 5 different teams engaged to help us out with this. And they go out and get those people in, and then they coordinate all the response for us. So this is a much better place that we've gotten to. Here's a much worse place that's still persisting despite all of my efforts to try to make it better. For 4.5 years, I was responsible for Apache Kafka at LinkedIn. For the last year, I've been doing capacity engineering instead. And we are still fighting with unclear monitoring signals in Kafka, to the point that before I left the team to take up a new challenge, we had 6 months of digging ourselves out of a monitoring hole that we dumped ourselves in, where 90% of the alerts we got were non-actionable. I was on a thankfully it was a 12/7 on-call shift where I was only on call daytime hours. I picked up an alert that paged me every 3.5 minutes for 12 hours solid. And then I went off call and came on call the next day and did the same thing. Most of those were being ignored. They didn't mean anything. So we spent months and months figuring out which alerts were not actionable and getting rid of them. The biggest culprit is this one. This is under-replicated partitions. Now, we have previously defined this as the gold standard for how to monitor Apache Kafka. I know this because I helped write the definitive guide for Apache Kafka, in which I declared that under-replicated partitions was the gold standard for monitoring Kafka. I now have to spend a lot of time eating my words and telling people that I told them wrong. I even went back and forth for a while with my co-author, trying to convince her that I was in fact wrong, and she disagreed with me. I found out last month when I was giving a talk about Kafka monitoring, and I threw Gwen under the bus once again with this statement. I talked to her afterwards, and she told me, now that I'm responsible for running a large Kafka deployment, we're not monitoring under-replicated, well, we're monitoring under-replicated partitions, but we're not alerting on them. Like, see, I told you so. The problem is that the alert says lots of different things, and it's not always a problem. So under-replicated partitions just means that one partition in Kafka is not fully replicated across the cluster. That happens naturally when you're moving data around. The partition is under-replicated until it's fully moved, and then it's replicated again. So we would set the threshold for this alert at 10, because we never moved more than 10 partitions at a time. So it could stay under 10 and it was okay. This graph, this is a nice simple graph. This tells me that a broker's down because there's a whole bunch of under-replicated partitions on lots of brokers and it's all consistent. This one's not too bad. This one tells me that there's a producer problem. I know that because I have 4.5 years of experience with Apache Kafka. Nobody else is going to know that by looking at it. I have no idea what this graph means. I never have. So do we care? Does the customer care that the partition's under-replicated? The answer is generally no. So these things get ignored all the time. They don't indicate an actual problem where the service is down. Here's another great one, CPU load. I love this. Not only do we not know what this means or what good or bad is, I guarantee that most people in this room don't even know what CPU load is, how it's calculated. Who does know? 1, 2, okay. So there's a handful. That's about the ratio I would expect. It is in fact a ratio of running processes. It's horrible because there's no good number. If you have 32 CPUs in a system, then 32 or above is bad. But if you have 24 CPUs in a system, then 24 or above is bad. If you have 12, then it's 12 or above. We have alerts set up on this, and nobody understands what it actually means because CPUs are supposed to be busy. Like, you should be doing lots of work on your processor. If it's at 90%, it's not a problem. The classic example I use for this is an interview question. So you're running an email server, and the email server is running at 99% CPU utilization. What are you going to do about this? And the candidate says, well, is it delivering email? Yeah. Okay, then I'm going to go get a coffee and ignore it. It's doing what it's supposed to. Why do we care? So this could be lots of things. I don't really care. This doesn't indicate an actual problem to me. So if none of these indicate actual problems, what do we have to do? What should we be monitoring? How should we be attacking this problem? The answer is we have to define what our goals are first. You have to make sure that you're looking at the right signals, and so you have to understand what do you care about? What actually matters at the end of the day? So I'm going to use some terms that I'm going to get into here. Let's start with service level. So many people use these terms wrong. So you probably hear the term SLA a lot, and you don't actually mean SLA, you mean SLO. So we have SLI, which is your service level indicator. This is a metric, generally. It is the thing you monitor. It is the thing that tells you about the quality of your service. The SLO is your service level objective. This is, for lack of a better definition, a threshold on that metric. So it's what's good and what's bad when it comes to measuring the SLI. Most of us have SLOs. We do not have SLAs. Because an SLA is a combination of an SLO and a penalty. So that's where you have an agreement with your customer that says, if I do not meet this particular level of performance, then I will pay you money. Most of us are running internal systems of some sort, and we do not have an agreement with our upstream callers that they are going to come and extract beers from us in exchange for performance failures. By the way, SLT is in here as well because that is supposedly the new standard term that replaces SLO. Service level target. You can use them interchangeably. It doesn't matter unless you're really talking to someone who's going to be strict about industry standard definitions. Then they're probably going to want to use SLT. So SLOs are where we start with for what we should be monitoring because this is what our customers care about. The other thing that you need to do is in setting your goals for your system, we can use the SMART system for this as well. So specific, measurable, agreed, realistic, and time-limited or testable. There's like 16 different ways of expanding SMART, so we're going to use mine today because I'm the one up here with the microphone. You can argue with me later, but not in this room. I'm happy to argue with you out there. So what this is, and this should apply to our SLOs and our monitoring as well. You need to monitor specific things. You need to be able to measure these things because otherwise what are you going to monitor anyways? And SLOs in particular, they're agreements. You can't say as the service owner, my SLO for latency is 100 milliseconds, because your customer is going to come back and say, that's great, but if you don't respond within 50 milliseconds, then the service is going to fall over and die. You have to come and meet in the middle on this. You have to find the common ground. There is a certain amount of performance that you can actually do, and there's what your customers need. And you may say that, well, I can only do 100 milliseconds. And then you have to turn around and say, okay, well, if you really, really, really need 50, then we have to find a new solution to this problem. Or maybe can you fail in a safe manner or something that's useful for the user? But again, you have to discuss it. You have to come to an agreement. If you don't come to an agreement, then one of two things happens. Nobody uses your service because it doesn't work for them. Or you have an SLO, but you actually have two, because you have what you think your SLO is, and then you have what your customer thinks your SLO is. And this is one of those cases where the customer is, in fact, always right. So don't be in that position. Clearly define it and agree on it. It has to be realistic. As I was saying, you have to actually be able to meet this thing, and you have to be able to test it. From a service owner point of view, if you can't monitor your SLO, then you're in a really bad spot because you don't know what your customers are actually experiencing. So what are some common SLO? Wow, what happened to that? Okay, I'm going to click this a couple times. There we go. Okay, I'll debug that particular problem later. There's a funny story behind this. Ask me later if you want to know why I have that problem right now. So what are some common SLOs that we're going to deal with? A lot of times they're going to revolve around availability, latency, or correctness. So is the service able to handle its requests? Does it respond to the requests fast enough? And are the answers to those requests correct? There is a much larger discussion around this about what site reliability engineering actually is. I'm not going to get into it here, but all of these things are pieces of reliability that are not actually the word reliability, except maybe availability. So again, you're going to talk to your customers, you're going to agree with them about what these SLOs are. So now that we've gotten some of the terminology and definitions and we've talked about SLOs to death for the moment, let's move on to what monitoring actually is. There is nobody I'm aware of at this conference yet who is really going to like throw a fit over what I'm about to say, I hope. But hopefully some good questions afterwards. The definition of monitoring from the OED is observe and check the progress or quality of something over a period of time and keep it under systematic review. This matches up with what we generally know monitoring is. We're watching our system, we're measuring it. So what the heck's observability? This is a great industry term right now. It's not that bad. It really isn't. So observability comes from control theory. It's a measure of how well the internal state of a system can be inferred from the knowledge of its external outputs. The important thing is it's a noun. You can't do observability. You get observability if you have good monitoring. And monitoring comprises a lot of things. They're also not really opposites. They're not different things. They are things that you get together in a system. So, you know, there are people who use this to indicate some magical new way to solve all your problems. There are definitely tools that will help you get better observability into your system in certain ways. And there are places where you use certain types of monitoring and you don't use other types of monitoring. Now, I'm going to get into types of monitoring in just a little bit. First, we're going to go for a really fun diagram that I have. So what do you want to get out of your monitoring? I'm going to call this the Rumsfeld quadrant. For those of you who are not US-based and don't know who Donald Rumsfeld is, he was Secretary of Defense in the US. And back in the early 2000s, he was raked over the coals for a statement he made in a press conference about weapons of mass destruction, saying that there are things we know and there are things we don't know, and there are things we don't know that we don't know. He was ridiculed for it at the time. What's great is that we've come to understand, like we know what he meant, and he was being very smart about what he was saying. There are lots of things that we don't know about our systems. So, along one side, we're going to talk about the detection of problems, whether or not we are able to know that we have a problem. And along the top, we're going to talk about the response to those problems, whether or not we know how to respond to or fix a problem. So if you know how to detect a problem and you know how to fix a problem, that's great. You have good monitoring in place. You know how to fix the problem, so you should automate that. Great, no problem there. We don't need alerts for that. You can automate the solution. So if you know how to detect a problem, but you don't know how to fix it, then you're in the middle of an active incident. So you're going to solve that problem. As soon as you solve that problem, you're going to know how to fix the problem. Now you have a problem that you can detect and you know how to fix. Great, automate it. Don't need to alert on that either. If you don't know how to detect your problem, but you do know how to fix the problem, then you have a monitoring gap. Okay, add more monitoring. You've solved the problem. Now you know how to detect the problem. You know how to fix the problem. Automate it. Recognize a pattern here? Everything moves up and to the left into that automation phase. The only thing that we're going to have a problem with is when you don't know how to detect a problem and you don't know how to solve it. And you don't know that you have a problem either. This is where people are ridiculing you on Twitter because your site's down. This is the only thing you need to alert on. I love the reaction to this too. I love this. People have come up to me afterwards and said they really like my Rumsfeld quadrant. I'm not the first person to come up with this either. I can't take credit for the idea. But this is the only thing that you actually need to alert on. But I already said that we don't know how to detect this problem. So how do you alert on a problem that you don't know how to detect? Well, if you monitor what your customers are seeing, then you can detect the problems that you can't detect. This is the only thing you actually need to alert on. So what do we have to work with? We've got a lot of tools in our monitoring toolbox, and they've gotten better over time. And definitely some of the larger companies who have developed good tooling are now sharing it, either willingly because they've released it as open source, or unwillingly because their employees have left and started up their own thing doing that stuff. Either way, we all get to benefit from it. So we've got metrics and events. These are two general categories of monitoring. Under metrics, single numbers. These are, rates, they are counters, useful information for threshold monitoring. Over on the event side, we have structured data. This is where we have wide, deep information about our system. This is not really something you can alert on easily. You can alert on counts of events, but you can't always alert on all the data inside the event. Because if you alert on something inside the event, then you've probably moved back to a metric anyways. You can turn events into metrics. You can't easily turn metrics into events, however. That's really hard to do. So if you're going to pick one or the other, start with the structured data and then derive your metrics from that. So underneath metrics, as I said, counters, gauges, histograms, 95th percentile, 99th percentile, wonderful. Under the event side, we have log messages. We have tracing, collections of events. These are all useful tools. They all have their place where we can use them in our system. So if you're setting up alerts, you're often using metrics. If you're debugging your problem, you probably want more structured data, more events in place to be able to understand what's going on. How do we get the data? You have subjective measures and you have objective measures. Subjective measures are the system measuring itself. Objective measures are external measures of the system. So you have rich data on internal state when you do subjective measures. You can introspect your system very easily. This is necessary for good observability. Your system has to tell you about the internal state of itself. You can't get this from outside. There's lots of data possible. The utility is often questionable. Do you really care about how many entries are in a given array? Probably not, until you do, and then you're going to want to get that information. But you can always add that later. You can generate reams and reams of data that you're going to have to throw away constantly because there's just not enough disk space in the world to store it. The other problem is that you're going to generate some problems with subjective measures, particularly when it comes to SLOs. A good example of this is your service up or down? Well, if your service is up and running, it's going to tell you it's up and running all the time. Your customer doesn't really care though, because the network's broken between them and your service. So you're not getting a good view of your availability with a subjective measure. So we can look to objective measures for that. So this is more of a customer view of your system. We call it external monitoring. We have services that do this for websites, things like Catchpoint, that will monitor your service from an external point of view. We also have individual tools, like for example for Kafka, we have Kafka monitoring that we developed for doing external monitoring of our Kafka clusters. Very simple, down for everyone or just me. Is a website actually down, or is it a problem that's individual to you? This is what you really need for SLO monitoring. You need to know what your customer's seeing. That's the only way to actually know what your SLOs are. A service can measure the latency of requests at the server, but that only applies to how long the server was processing that message. It doesn't include the amount of time the client was waiting to send it, waiting for the response, how long the network took. So you really need to look at the SLOs from outside the system. This is a lot more difficult to do. You need more components in order to do it, but it's always going to be the authority on whether or not your service is broken. So we understand what we can do. So we can move into how we design our systems to support this now. We want to have enough data to monitor our system. We don't want to kill ourselves with too much data and information overload. So you start with designing your service the right way so that you don't have to monitor every single metric you have. Start with building for failures. You have to assume that your service is going to fail all the time. And you want to be able to tolerate single component failures or dual component failures, or however many you want to be able to suffer through the night so that you don't have to worry about these. So you want rich instrumentation on every aspect of your system. One of the things that you'll hear is you should collect monitoring on as much as you can possibly store. That doesn't mean you should alert on it, but you should collect it, because most of this information is going to be useful at some point in time. You may only need it for a few days to debug a problem, but you are going to need it at some point. You also want good availability. So as I was saying, you want to tolerate single component failures, but that doesn't mean you just want N+1. So we got into this dangerously in the Kafka space. So you have Kafka brokers, and they all have their amounts of data, and you use replication factor 2, so you have 2 copies of every piece of data. But that means you can only have one server go down. As soon as one server goes down, you're in a crisis state, because if one more broker goes down, the whole cluster is going to go down and everything's going to hit the fan. That's not really good availability. So what should it be? N+2? N+3? You have to define for each system how many failures you can tolerate at any point in time. A good guide is how many failures are reasonable to happen in a single night or a single weekend, so that you can get through a down period without having to respond to every single thing going on. But that's just one place to start. And then you have to worry about capacity as well. The best way to worry about capacity for a service is to limit the resource creation and utilization from the start. Do not make it a free-for-all. We made this mistake with Kafka as well. If multi-tenant system with absolutely no capacity controls, that works out really well for everyone. So if you put in quotas to start with, if you limit the way people can create resources, you can then control your capacity and reason about it much better. We'll talk about capacity a little bit more in a bit as well. So now we're going to get back to SLOs. The only thing that matters is the SLO. You want to always monitor your SLOs. If you don't, then you don't know what your problems actually are. Objective monitoring is best when it comes to SLOs. You can make do with some internal monitoring if it's all you have, but you should definitely trend towards objective monitoring. You also don't want to beat your SLO by very much. If you say that your availability is 99%, but your service is actually up 99.99% of the time, then guess what? Your availability SLO is 99.99%, regardless of what you're telling people it is, because they're going to assume that your service is up that much. This is why, contrary to popular guidance, a lot of people will tell you to take your service down regularly if you're meeting your SLO. Have maintenance windows where you just take it offline, regardless of whether or not you actually need to do maintenance. Have periods of time where it's not working properly or degrade the quality of the service so that it just beats the SLO. Your service only needs to be good enough. You don't need to, if you're doing 99%, and all your customers need are 99%, you don't need to go and stretch and reach for that extra 9. You don't need to continue getting better. Use that time instead to take risk, to deploy new features that might break and might need to be rolled back and therefore will eat into your SLO. And only alert on the SLOs. Do not alert on anything else. I know, I must have made a mistake there. There must be something wrong with that statement because we have lots of things we need to alert on. We have to know if servers are down. Well, think back to the Rumsfeld quadrant that I described. SLO alerts find your unknown unknowns. These are the only things you really need to alert on because everything else can be automated away or is an active problem that you're working on. Anything in the middle only exists transiently. And everything that's known can be handled by automation. If it's not handled by automation now, you should be moving in that direction. We don't all start with automation in place, but we do get there pretty rapidly because we don't want to push the same button over and over again. For everything else that you think you might need to be alerting on, ask the question about whether or not the signal is 100% clear. Do you always know what needs to happen every time that alert goes off? Under-replicated partitions is not that type of alert. We don't know what needs to happen every time that alert goes off. And it doesn't impact the SLO either. So if it doesn't impact the SLO and it's a false signal part of the time, then do I really need to alert on it at all? I only need to wake myself up if I'm going to miss the SLO. And I will say here that SLO monitoring itself is not really sufficient. You don't want to know if you just go over the SLO or if you're under the SLO. You actually want to go and watch Jamie Wilkinson's talk from last year at SREcon about SLO burn rate, because the burn rate is what you actually want to look at. You want to know how quickly you're moving through your SLO for the period of time. But that's way more than I can get into here. But what about capacity, you say? I have to alert on capacity. I have to monitor, how much capacity my system has and respond to that. So surely I need to monitor disk utilization and other things like that. Well, no, you don't. Use quotas. Once you have quotas in place, you can actually plan for your capacity a little bit better because nobody can overrun what your capacity is. You're going to report on capacity and you're going to review it frequently enough to respond to capacity issues. And when you have a capacity problem, when you identify that you need to do expansions, you need to act on that promptly. The reason you can't alert on capacity issues is because nobody here can magically produce a 2U rack mount server right now, can you? No, you can't. And you can't do that in the middle of the night when you have a capacity issue either. Because if you have that extra capacity sitting around, why aren't you using it already? And if you can automatically put it into place when you need it, then why are you alerting on that? That's automation. You don't need to handle that either. So you can't quickly respond to this problem, so you have to plan for it in advance. With that said, I'm actually through the bulk of this talk now. So we'll have plenty of time for questions coming up. But before I do that, let me go over some of the high points again and make sure that we've got a good plan for moving forwards here. So what should you do next? You want to get out of the hole that you're in with monitoring. So start with defining your SLOs. Talk to your customers, agree on what they can expect and what they need, and add objective monitoring to get to be able to see what's going on all the time. Clean up all your alerts. Take an inventory of everything you're alerting right now. Eliminate everything that's not a clear signal. Add alerts for the SLOs that you just set up monitoring for. And implement quotas if you can and if you haven't already. This is hard to do after the fact because you have to change expectations about your system. But If you have reasonable internal customers, then it won't be too difficult for you. They're probably going to want to work with you because they want your service to be up all the time. If you have external customers, that's a different story. You're going to have a discussion about that. Can't help you. Add more instrumentation to your system. So if you're not doing it already, switch to structured logging. We're probably all logging in our applications. Many of us are doing it badly because it's not structured. Structured logging is much easier to parse. Aim for your logs being targeted at computer processing and not human processing. You don't really care if your logs are human readable. We should not be optimizing for humans reading the logs and extracting content from them. Humans need to look at derivations of information in those logs. If you've got a distributed system, consider adding request tracing to what you're doing. If you don't have this capability within your organization right now, it is perfectly okay to buy that in. There are excellent services out there. And after I kind of threw them under the bus without naming them earlier, I will say that Honeycomb has an excellent product when it comes to distributed tracing. So buy in the product if you don't have it already. Don't hold that information for any longer than you actually need it for debugging, though. You're going to generate a lot of data in those spaces, and you really, the ideal thing would be to be able to get like the last hour's worth of debug information when you need it, and then collect debugging information for a period of time until you solve your problem, and then throw it all away again. I would guess that some of these services have solved that problem for you already. Again, look into it if you don't have it already. I do have some more resources for you, and all of these are in the slides that you downloaded, so hopefully you took the picture up front of the QR code. Code Yellow is, I kind of alluded to this with the Kafka problems that we had a couple of years ago where we spent 6 months solving them. This is a process that we have within LinkedIn for how we help overburdened teams. Teams that either have high toil, they have application problems, they have communication issues with a counterpart team. I've written a blog post on this for devops.com, so you can find a good description of it there. My colleague Michael Keogh and I also gave a talk on Code Yellow at LISA last year, where we went into the process and gave a couple of use cases. I'll be giving this talk next week, but most of you won't be there unless you happen to be working for Microsoft, and we'll be in Redmond next week. If you want to know more about SRE and what culture looks like at LinkedIn, we've given several talks on this. I gave a talk last year at this conference about building SRE and kind of how we got into it with LinkedIn. I also have another talk that's posted similar to this that goes into a little more detail about how you build SRE teams from the ground up. Honestly, it all comes back to blameless culture and open, honest, and constructive communication. Once you have those two, you can do lots of things. And actually, you really only need one, because if you're open, honest, and constructive, then you have to be blameless by definition. You can't be honest unless you're not blaming people all the time. There's also a great blog post series called Every Day is Monday in Operations, and you can find it at everydayismondaynoperations.com. This was written by one of my colleagues and someone who unfortunately left LinkedIn just before I was hired, Ben Pergeson, who's now our head of house security, and David Hankey, who is our VP and was largely responsible for founding SRE at LinkedIn. They've gone into lots of use cases and problems you run into. It's a great read if you have the time. And then if you want more information on Kafka itself and a deep dive on monitoring for Kafka, which is similar to this talk but very focused on Apache Kafka itself, I gave a talk at Kafka Summit London last year called ERP, Excuse You. ERP is under-replicated partitions. It's a nice clickbaity title. I get into a lot more than just 3 metrics because I pretty much throw out 3 metrics to start with and then give you the real talk about what you need to monitor. And if you'd like to talk to me some more, I will be around after my talk and for the next couple of days. Please come find me. I'll probably be hanging around the LinkedIn booth a lot if I'm not in a talk. You can also connect with me on LinkedIn. I post all my presentations on SlideShare, although, as I said, they're all going to be PDF downloads, so I'll do something about that as soon as I can. Or you can find me on Twitter, but fairly infrequently. I don't tweet a whole lot. With that, I am done talking at you, and I would love to take any questions that you have right now.
Please go to the mic to ask questions. Sometimes teams are on call for a lot of different services, and if you get paged for an SLO alert, what does the runbook look like for that?
So when you have an SLO alert, you then need to start with finding out what that SLO alert actually means. So you've alerted on something that you don't know what the problem is. This is where you have to engage that debugging information. So you may start with looking at other metrics that you've been collecting and see if something is off. So if you're in high GC, for example, you're going to indicate that with a metric. Now at that point, you then need to dig in with the debugging information to find out exactly where the problem is. You may have to engage your debugging mechanism at that point, turn it on and start collecting information. You may be able to collect the information you already have. But either way, the process is going to be the same. You need to dive into the internals of your system and find out why that's happened. That's where that observability work comes into play, where you have that debugging information to go look at.
So no more like cookie cutter solutions to known alerts?
No, I mean, if the alert is known, if you know how to detect it, then you've automated it. And you don't have to worry about that. Your SLO alerts at that point are only going to tell you about things you don't know. There's no good answer. Like, I can't give you an answer about how to identify what's triggering your SLO alert. It could be lots of things. If your SLO alert's going off, but the service says it's fine, then maybe you start with looking at the network between them to start with to see if there's a problem there. If the network's fine and the service says it's fine, well, maybe you're going to start looking at the number of requests that your service is actually getting. Is it not logging the requests at all? Is it throwing them away? Is it, if it's a web-based service, is it returning 400 errors? Are you throwing 500 errors? If you are throwing 500 errors, you're going to go in and look at your logs and see what's actually going on at that point. But all of that work is why we get paid the big money. That's where we have to go in and exercise our skills to actually find the problem that's going on. No more questions. Everyone agrees with me? Awesome. Oh. Okay.
I just wanted to ask how that behaves when you have, for example, 4 or 5 nines, which means that you should react in 5 minutes. Adding this extra layer of debugging, and also how does this interact with redirecting the alerts to the right team? Mm-hmm. Because if you alert based on your SLO, then it means you are paging only the SRE, right?
Exactly. So when you start talking about high availability services, you have to put much more effort into designing for failure. So you have to put more effort up front into being able to tolerate component failures and tolerate component failures at a number where you can address them before it becomes an SLO violation. The other thing that you need to invest in is you need to look at the SLO, not just whether or not you're within SLO, you need to look at the burn rate of your SLO. So that 4 nines or 5 nines is going to be measured over a period of time. And if you have individual failures over that course of time, you want to track the slope of those failures. If it's going up too rapidly, then you're going to be able to respond before you hit the SLO, before you hit the overall SLO failure for the period of time that is. If the slope is low, then you can tolerate failures over time. But it definitely comes back at that point to designing your system for failure to start with. Don't assume your system's going to be up all the time. It's never going to happen.
Okay. Thanks.
Hi, really good talk, first of all. I totally agree with alerting on SLOs, except that I have a caveat. I like to alert with 2 thresholds on SLOs, because SLOs, only alerting on 1 threshold in SLOs means you're already making customer impact. So your customers are already impacted by the event that's going on. And normally I like to always say, well, you always have a preemptively one with a different threshold that's a bit more aggressive for early visibility for the team to have a shot actually resolving the event before it actually hits the customers in a bad way. What's your take on that?
So you can certainly set the threshold for your SLO monitoring lower than your actual threshold. Just make sure that's actually something you want to do. Because if your threshold, let's say your SLO is 100 milliseconds of latency for requests, and you set your threshold at 90, and you're always at 91 milliseconds. The alert's always going to go off but it's not actually a problem. This is where I'm going to refer back to Jamie's talk about the burn rate on your SLOs. You don't actually want to monitor the threshold of the SLO. What you want to know is for each request, was that request in SLO or out of SLO? Now, that's a little more difficult to monitor, but once you have that, that becomes an event. And the count of the number of events that were SLO failures is what you end up monitoring on instead. So over the course of a week, you may be able to tolerate 1,000 failures and still be within SLO. If you hit 100 failures on Monday, you're fine. 7 more days, 700, that's a 700 total failures projected. You're okay. You're within your SLO. If you hit 500 failures on Monday, you have a problem. So your burn rate metric will tell you about that problem before you actually go over your SLO and give you some time to react to it. Then you can make the decision, do I need to roll back a piece of code that just went out? Do I need to pay more attention to service failures of some sort? You then have to dig in and find what your problem is. But definitely move towards the burn rate and not just the straight SLO monitoring. Personally, I would not use 2 thresholds.
I see how I see how to measure the availability of a service when it responds to a request, like a pull model. But when my service is just a source of data, a stream, which doesn't respond to requests, but just sends data when it makes sense to send data, how can I verify that it's really working as expected?
So let me try to restate this and make sure I understand the question. So you've got a service that is streaming data, so like an Apache Kafka consumer, and you want to be able to monitor the SLOs on that service and react to them appropriately. So first, let's define what your SLO is. Are is it latency based? Is it data completeness based, like that you're getting all the requests? That's what it is? Okay. So we actually do some completeness monitoring for LinkedIn for our Kafka deployments. We measure it externally, so we count all the messages that go through the system and make sure all the counts match at the various tiers. The consumer can do that as well, provided you own the consumer to some extent and you can extract metrics from it. You can put that same audit counter into the consumer. In that way, the consumer provides the metrics for the SLO monitoring for you. The application actually becomes the external monitoring for your app. That's the best way to do SLO monitoring as well. If you can get the clients to tell you whether or not things were in SLO, then you honestly don't have to spend money on external monitoring. You've already got it already. That's how I would end up implementing that. I would have the consumer expose the audit metrics about the counts that we're going through, and then I can identify, oh, it's missing one message every once in a while. This is something I need to respond to if it's going to breach the SLO. Like ours was 99.9%. 0.1% actually turns out to be a whole lot of data you can drop before people start complaining. Good. Yes?
Hello. You made a very strong statement that we need to alert only on our SLOs and we don't need to engage quota. We don't need to alert on quota. And people are not perfect. People make mistakes, and they do them very often. It's very easy to forget about a new launch, new client, new traffic, whatever new, or just you release a new component and your fan out is a factor of 2, not a factor of 1. As a result, we will have issues, and if we wait until the very critical state of the system when we already started burning our SLO or started alerting on our SLO because we had, I don't know, maybe 50% of headroom and now it's exhausted. Maybe in a case if we see that we are very close to the end of the quota, we can start load shedding or prevent load in any other way. Basically, the question is how you can embed the idea of non-perfect world and that people make mistakes and forget about provisioning with your strong statement that we can alert and need to alert on SLO only?
Sure. So quotas go hand in hand with limited resource creation. Nobody should be able to, and so I speak about this from the point of view of a multi-tenant system that implements quotas. Nobody should be able to create resources or create new quota allocations on that system without my knowledge as the service owner. So instantly, if there's a new service, I'm going to know about it when they apply for new quota, when they ask for more quota. Now, I might automate that process, but I'm still going to have the information available to me. And I know what the maximum capability of the system is. So my quota allocation system should never allocate more than 100% of the quota available anyways. I should never alert on quotas as the service owner because I don't care. I care that the quotas are allocated properly and that that system is doing its job properly, and monitoring that system is a whole other problem. But I don't care about your quota utilization as my customer. Your quota utilization is your problem to alert on. You have X amount of quota, and if you use 100% of that and start dropping requests because of that, you should have metrics available to you to tell you what your quota utilization is. So from the start, quota utilization becomes a problem on the client side. As a service owner, I don't know how to react to it anyways. If your application starts using up all of its quota, I don't really know what to do about that except to call you. And if my response is only to call you and find out what's going on, then you should have gotten that alert directly in the first place because you're the person who has to react to it. But as far as alerting, making that mistake and running over the top of your quota utilization, it comes back to making sure that your quota system can never do that in the first place. Now, that doesn't mean that it won't. It doesn't mean that a mistake won't be made in that system and you will accidentally allocate 200% of your quota when you didn't intend to. That's an incident, and you're going to handle that incident and then move forwards. One of the things that we did in Kafka space that I regret to this day is we had a problem at one point with open file handles. We were running over open file handles for our Kafka brokers. The problem turned out to be a socket leak in one part of the code. So it was a bug in the code. So when this problem started happening, we added an alert for open file handles so that we could detect the problem happening. We didn't know what the solution was yet, but we needed to detect the problem happening. So we added an alert for open file handles. That's okay. But then we solved the problem. We found the socket leak, we fixed the code, we rolled out the fix, we verified it. The alert should have gone away at that point because it was no longer useful. That didn't happen. The alert persists to this day. And what happens is we slowly creep up file handle utilization normally because you have more and more traffic into the system. And then eventually the alert goes off when it reaches the threshold, but it's not really a problem. It just means we're expanding the use of the system, and there's no real reaction to that alert. It's the same thing with a problem in your quota allocation system. If you accidentally allocate 200% quota because of a bug in your quota allocation system, you have a bug. So you fix the bug, and then you add a test later to make sure that that situation can't happen again. So you move all of your alerting out of alerting, and you move it to, your point of view, you move it to the left into your testing process to assure that you've checked for that problem in the future. But continuing to maintain an alert on that because it might happen again, that's just going to get you into the same place where you have lots and lots of noisy alerts that don't actually mean you have a real problem.
But it seems to me that we are kind of outsource the problem to the client side.
The only problem we've outsourced to the client side is monitoring their own quota utilization. And monitoring your own utilization of systems is something that the service owner should be doing anyways. Again, I can't do anything about you running over the end of your quota except to give you more quota, and that's probably not the right answer to that problem. We need to understand why you're running over your quota. Did your request pattern change and you didn't tell me about it? Did you fail to project your quota utilization properly? That's fine, we can increase the quota, but if we're going to increase the quota, we need to know that it's the right response. Ultimately, as the service owner, as the client, you need to be the one to make that call and to understand what's going on. I can't fix your problem for you.
Gotcha. Thank you.
Yep. Yes.
Hi, so I have a question about the logging part. So I totally do agree with you that we should be able to log everything, especially the internal state of the software, so that when it's needed, we have the thing, because what's past is past, what's gone is gone. If you don't log it, you don't know.
Yep.
Until you start running out of disk spaces with these, and then the other problem is now. I don't know how in Lincoln you guys deal with this, but then in my company, we actually have a system to centralize these things into a storage space. You start getting into the capacity issue of the logs. How do you guys deal with that?
So for the most part, we don't send all of the debug information to the centralized system. You monitor warning levels. Maybe you monitor info if you're really a masochist and you want way too much data. But we don't send the debug information in. And for the most part, we have debugging turned off unless we go in and turn it on, which doesn't solve the problem of capturing what just happened. There are solutions for that, though. For example, you can use a ring buffer on the local system and write your debugging information to that and constantly overwrite it. And then if you need to get that information, you use the control plane for your application. You say, okay, start logging that information. So then maybe it dumps the ring buffer to your centralized system and continues to dump debugging information in for a period of time until you tell it to stop. So there are technical solutions that you can come up with for this that will not exhaust all of your disk utilization.
Hey, so my question is, what can we go back and do on Monday? So right now, I have a lot of known knowns, I have a lot of known unknowns in my system. I can't automate them today or next week or the week after that. It's going to take me a while. So do you suggest that we get to the SLO-based alerting first and then automate as you go on, or automate first and then get to SLO? Because automating all the time is...
Automation should always be your first priority. Getting rid of the toil is going to free you up to do more work as you move forward. So you should always focus on getting rid of the toil. And you know as well as I do, that's what the code yellow process is for in a lot of cases. It's eliminating toil in your systems. So my suggestion would be to automate your responses first, and then use that time you free up to start eliminating the alerts and improving the SLO-based monitoring. Now, I could give you the simple answer and say that the thing that you should do on Monday is go back and turn off all the under-replicated partition alerts, because I know what your job is. But it's not as simple as that. I mean, I've had that argument already, and it's a difficult problem to solve because we've become reliant on them. But the first thing that you need to do is define what the SLOs are. That's the problem that hasn't been solved yet. You need to figure out, is it latency, is it availability, is it a combination of the two, and describe it in a way that can be understood by the clients. This is non-trivial for a distributed system that has multiple types of requests that can vary all over the place. But you can answer the SLO question for average types of responses, and then measure the average request response and base your SLOs off that. The best answer I have for you is do something. If you freeze up because we can't solve the problem perfectly, then we're never going to get anything done. Start somewhere. Start defining an SLO for requests in the median range, even if it's wrong. Like, start with your best guess and then iterate on it from there.
But my question was more about, in large companies, right, you're going to have issues where you can't really automate away all your known knowns and known unknowns as well. So it's going to take a long time. So this seems like an ideal state where you can get to in a few months or a few years, but I think the gist of what you said was do something first and then we can
Yep. Take one step. So you don't need to automate the response to every single alert you have right now. The next alert that goes off, spend a little time and automate the response to that one alert, and then eliminate that alert. And then when the next alert goes off, spend a little time, automate the response to that one alert, and move forwards. We don't need a perfect solution. We just need to take incremental steps forward until we get better.
Thank you.
Thank you.
Yeah, I've just got a question around, I guess, ownership of monitoring. So I spent a year being on call for a system that was a critical system, but the monitoring system that monitored it was basically falling over all the time. So I was getting 2 o'clock in the morning calls. But I think there's a question around trust of, is it the SRE team that owns that monitoring, or is it the third party that can provide external synthetic monitoring? And I guess there's some questions around that. How do you trust the team? Yeah.
So it depends on who's doing your monitoring. So if you have an internal monitoring system like we do, then I have to trust the monitoring team to monitor their own systems and respond to problems appropriately. They have an SLO, whether it's stated or not stated, an expectation that I have of how they're going to perform. And they have to stay in line with that. If you have an external monitoring service, like say you're using something like Catchpoint for doing external monitoring of your systems, then you have an SLA agreement with Catchpoint. They're going to perform a certain way, or you're going to get money back on your contract. Now that money may be cold comfort if you're failing your clients as well, but at least that's the agreement that you have to start with. But again, that SLA becomes the trust that you have with them. At some point, you need to release control over that a little bit and be able to know that their system is doing what it's supposed to. Okay. One more? Okay.
Hey, the last question probably. I have a question around the slide that you showed, the list of service levels, whatever, and I saw an item around the SLT. So you did mention that the SLO and the SLT are almost the same.
Yeah.
Why reinvent another term? So what's behind the...
I'm pretty sure it was ITIL, so it's the ITIL definition that redefined it as SLT instead of SLO. I have no idea what the reasoning was behind changing the name from SLO to SLT. I'm sure they have some explanation why they did it, but they mean the same thing. They're both targets. They're both objective. The objective and the target are the same thing. You're taking the SLI and defining what the bounds are on the SLI.
Okay, thanks.
Okay. Thank you very much.